Hello guys, so we are going to continue discussion with respect to multiplication of vectors. The second type that we are going to discuss about is something called as element-wise multiplication. Okay. Now, why this kind of multiplication technique and what is the application of this? We will be completely discussing about it. Okay. So in element-wise multiplication, corresponding elements of two vectors are multiplied to form a new vector of the same dimension. Okay, of the same dimension. So let's talk about this element wise multiplication and how exactly it is done. Okay, so let us consider that I have a vector which is like A. Let's say this is a 3-dimension vector. Okay, and this is B, right? This is basically also a 3-dimension vector. So let's say go ahead and write 3, 4, 5. Okay. Now, whenever we talk about element-wise multiplication, this is basically given by the notation, something like this. Okay. So this is nothing but element-wise multiplication. Now, element-wise multiplication says that when we are multiplying, we are just going to multiply the corresponding elements of the two vectors. Let's say in this particular case, whatever will be my x coordinate 1 and 3, we will try to multiply it. So this will be nothing but 3, 2 into 4 will be 8. And 3 into 5 will be 15. Okay. So this will basically be my end output. Okay. And this is how it is denoted by. This is the notation of specifically using this element-wise multiplication. That is the reason it is showed. It is given the name as element-wise. We are going to just multiply the corresponding element to form a new vector, and the vector will have the same dimension over here. Previously, we used to get a scalar. Okay. Now, why do we specifically use this? And again, with respect to applications in data science, I will just go ahead and talk about it. Okay. Application in data science. Let's say that I have an e-commerce website. Okay. And in this e-commerce website specifically, let's say I will talk about feature engineering. Now in feature engineering, what I'm actually doing is that I will just go ahead and say, hey, let's talk about this. Okay. So let's say that I have some products and this is the cost of the product. Okay. And this is the discount of the product. Okay. And this is the final price. Okay. Or let's remove this. And this is my 3 features that I have. Okay. Let's say I have A product over here. This is costing around $1,000. My B product is there. This is costing around $500. C is there. This will cost around $200. Let's say for the first product, I have a discount of 10%. Then I have a discount of 20%. Then I have a discount of 0.15%. Now, just by seeing this, understand this is one of the vector. I can consider this as my one vector. Okay. This is one of my vector and this is my another vector, right? If I just remove the features. Now from this, we will be able to derive my another feature, which is called as final cost. How do I derive it? Here I will just do element-wise multiplication. Okay. Once I do the element-wise multiplication, let's say this feature that I want to probably create is my discounted price. How much discount we are basically calculating. Now in the discounted price, if we just do the element-wise multiplication, you'll be able to see if I do 1000 multiplied by 0.1, so $100 discount is there. Here, if I just go ahead and do the calculation again, 20%, again $100 is over here. If I say 15, then $30 is over here, right? So just by seeing this, you are able to understand that how this entire multiplication is specifically happening, right? And this is my discounted price. Now here you can see that I have created the same dimension by just doing this element-wise operation, right? And through this, in feature engineering, we have created a new feature. And after this, I can go ahead and create another new feature. Let's say another new feature. The feature can be anything as such. Let's say the final price. And here this time I'll not do element wise multiplication, but instead I'll do element wise subtraction. So from cost I will subtract 100. From 500 I'll subtract this. Then from this I'll subtract this. So here you'll be able to see that I'll be getting 900, 400, and finally I'll be seeing 170, right? So this is a kind of EDN feature engineering that we specifically do with respect to any kind of data set that we have, right? And again, this is one of the another amazing techniques. Since you may not be having ideas with respect to deep learning, so in deep learning, some of the amazing neural networks, right? Let's say there is one neural network which we specifically use for text data, RNN. In LSTM RNN and in GRU RNN, you'll be seeing that we will be using in the architecture of this particular RNNs, right? There we use this kind of operation, that is element wise multiplication. We also use element wise addition, okay? And why do we use it? There is a concept of something called as forget gate, input gate, right? That is where we use these gates because you can see, right, once we do element wise multiplication, let's say that I have some signals over here. Let's say I have some values over here, which looks like this, okay? Let's say over here some values are like 0.5, 0.6, 0.3, okay? And if I consider my another dimensions or another vectors, let's say this vector is 0, 0, 1, okay? By just doing this element wise multiplication, you know, we can see that this can also act like a gate, you know. If the value is 0, if I do this operation of, you know, element wise multiplication, this information will pass through, right? Because this value is 0. So here I will be getting, this information will not pass because here we are multiplying with 0, right? So here you can see that I'm getting 0 over here, 0 over here. But over here with respect to 1, we are letting this particular information pass. So finally I'll be getting 0.3. So this multi-wise operations can basically act like a gate which can help you to pass information or not, right? Or not. So here you can see some information is not passing. Here also the information is not passing because when we multiply with 0, we are going to get it 0. But when we do this multiplication operation over here, or if we are specifically doing this element wise multiplication over here, 0.3 multiplied by 1, it is passing this specific information, right? So we can pass some information or not, and this will be very, very handy whenever we apply in some neural networks, because the architecture over there uses forget gate, input gate, and different types of gate, which is responsible in passing some of the information and not, right? So this was a good example in making you understand about element-wise multiplication. So I hope you got this particular idea. Again, in machine learning, in EDA, in feature engineering, we specifically use this, okay? So yes, this was it from my side. I will see you all in the next video. Thank you.